So there are different types of yielding criteria that will determine whether a material plastically yields via dislocation glide. So we're going to make assumptions that plastic flow occurs at constant volume, modest hydrostatic pressure, perfect plastic, isotropic material. There are going to be three yield criteria that we're primarily interested in. The first being Rankine. Rankine looks at maximum normal stress. This Rankine works great for ceramics, which are typically going to fail when normal stress is maximized, and it's simply maximum normal stress is greater than the yield strength. This misses shear, which is taken into account by Tresca criteria. Tresca is good for metals and other materials that will yield predominantly via maximum shear mechanisms. So you can see here it's the sigma 1 minus sigma 3. If we go back to our Moore circle, we can see that if we draw our full 3D stress state, that our maximum shear will occur at a value of sigma 3 minus sigma 1, or actually sigma 1 minus sigma 3, divided by 2. So this is your maximum shear stress criteria. So when sigma 1 is minus sigma 3 is greater than our yield strength, we determine that that material will yield. Worked well, except for it failed during World War II for submarines. So the von Mises criterion is a bit more comprehensive. It looks at maximum shear deformation energy. It's described by this huge equation, this sigma effective. It can be reduced in terms of principal stresses, and we can see when this material when this predicts when materials will yield. The yielding mechanisms of many different materials can be very different. So polymers are always a unique material. So we can see at basically yield, when you uniformly, or simple uniaxial deformation in tension, polymers can form shear bands. Those occur at regions of maximum stresses, which are 45 degrees relative to the applied stress. You can also get a craze formation, which is very unique to polymers. So what you'll find is when there is a micro crack or a micro void appearing, crazes or fibrils will form that connect essentially the cracked faces. And it's this cool combination or competition between stretching and surface area creation. So you can see these deformation mechanism maps, and the thing to notice here is that for certain criterion, it may predict in that second arrow, or actually we see here, Rankine and Tresca predict that material will yield, but von Mises may not. So you have to be very, very careful and determine which yield criterion works for your particular application and for your particular stress state as well. So be careful as you're choosing those. Don't just plug and chug. And next time we're going to get into a very nice discussion about strengthening mechanisms. See you then.